Now that you have read about measurement concepts and technical skills for assessment, I wanted to highlight some key points for review. We use measurements in our daily lives to make decisions. For example, if I step on a scale and my weight isn't where I want it to be, I know it may be time to make a change in diet. If I measure the temperature, I make a determination about appropriate clothing to wear. Like these tools, formal and informal assessment measures are used in the schools to collect data to make decisions about students. Formal assessment measures, such as standardized assessments, fall into the evaluation step in the assessment process, and scores help IEP teams determine eligibility. There are two essential components regarding the technical soundness of assessments. Validity is about accuracy. It answers the question, does the assessment measure accurately gauge the knowledge or skills that it is being used to evaluate? The degree to which evidence and theory confirm interpretation of test scores, as described by the test developers, is also an element of validity. Validity enables the appropriate interpretations based on the data or evidence collected from the instrument. Reliability is about consistency. It answers the question, does it measure this area consistently every time it is used? Examiners must be able to administer a test with minimal errors and interpret the results with confidence. For example, a science test constructed by you will be administered by a substitute teacher, and the same results indicate it's a reliable measure. Formal assessment measures like standardized assessments help us compare students to their peers. On the other hand, criterion reference measures compare student performance against set criterion. Standardized assessment measures are based on the normal distribution. This means that when you assess a variable on the general population, the scores will cluster symmetrically around the average score, with fewer scoring below and fewer scoring above. Hence the name, the normal probability curve, or the normal bell curve in reference to its shape. Three measures of central tendency which you may remember are mean, median, and mode. Mean is the average score. Median is the point on a scale above which and below which 50% of the scores occur, and mode is the score occurring most frequently. The first step in performing a visual analysis of assessment data is through a frequency distribution. To create a frequency distribution, you can organize the students' raw scores by making a table and graphing the results. A frequency distribution shows how frequently the scores occur within the entire set of scores. Some other important concepts are related to measures of variability. Measures of variability tell us about the spread of scores around the mean or average score in a distribution. Range is a quick estimate of variance, the difference between the lowest and the highest scores in a distribution. Standard deviation is the average distance of scores from the mean score. It is calculated by taking the square root of the variance. In a normal distribution, approximately 68% of the scores fall between one standard deviation below the mean and one standard deviation above the mean. 95% of the scores fall between two standard deviations below the mean and two standard deviations above the mean. Finally, 99% of scores fall between three standard deviations below the mean and three standard deviations above the mean. What this means is related to cognitive assessments. For example, on the Wechsler Intelligence Scale, the mean is 100 and the standard deviation is 15. That means approximately 34% of students have intellectual functioning between 100 and 115, while 68% of students have IQs between 85 and 115. Not all distributions of scores are normal or bell-shaped. Sometimes distributions are skewed. A negatively skewed distribution means most scores are low scores. A positively skewed distribution means most scores are high scores. A raw score for a test is not descriptive, which is why we convert raw scores into derived scores. In this example from Cohen and Spencer, you can see how norm reference testing enables us to make interpretations about student performance based on derived scores. For example, percentile ranks, or simply a percentile, is a derived score that indicates the position of a student's score on a test in comparison with other scores. A percentile tells us whose scores are at or below a given raw score. Another derived score that you should be familiar with is a z-score. Z-scores are a standard score with a mean of 0 and a standard deviation of 1. It is important that assessment measures are reliable measures. Factors that can affect reliability are the testing environment, student errors, the test itself, and test administration. For example, the testing environment. You want the environment to be as optimal as possible for students. Student errors. Sometimes scores are impacted by careless errors students make. The test itself. Not all assessment instruments are reliable instruments. Finally, testing administration can impact the reliability of the assessment if there were inconsistencies in administration. It is also equally important that assessment measures are valid measures. Factors that can affect validity include test reliability. That is, a test must be reliable to be valid. Test procedures can also impact validity. That's why deviating from standardized test protocols or directions for administration, such as giving extra prompts or more time, can make scores invalid because the condition was altered for that particular student. Finally, test norms can affect validity. For any assessment, the sample on which the standardized scores are based should adequately represent the population. The results can be invalid when used with individuals who were not represented in the sample. Before you administer any standardized assessment to a student, it is important that you carefully review the examiner's manual, which often provides information on the technical soundness of the assessment instrument. It's critical that you understand and interpret the findings in comparison to the normed group so that you can draw correct inferences and make appropriate instructional decisions.